Alright, this video will just be covering this page, Introduction to the Unit Circle. I guess more properly we could call this one Introduction to Thinking in Radians, okay? We're gonna try to get used to thinking not in degrees, but in radians, okay? So just as a reminder, an entire circle in degrees, and this is where we start, right? So this would where 0 degrees would be. An entire circle was 360 degrees, or it was 2 pi radians. So if we have an angle that starts here and ends here, we could talk about it being a 0, or we could say 2 pi. Right? And again, just a reminder, there's no unit on that, so that means that we're talking radians. This chart here we're going to use for all of our multiples of pi over 2. Pi over 2 is the same thing as, like, if you think of 2 pi, here I'm going to draw it like this, 2 pi is equal to 360 degrees. Right, so pi would be equal to 180 degrees, so this pi is going to be equal to 90 degrees. Okay, so let's think about all the multiples of pi over 2. So if we start here at our positive x-axis and we rotate pi over 2 radians, we get to this spot here. So we can put a little dot here and say that is pi over 2. So if our angle starts here and ends there, it's the same as 90 degrees, isn't it? But now we're thinking in radians, so now it's pi over 2. The next multiple of pi over 2, so 2 pi over 2, which is the same thing as pi radians, would be over here. So this spot on the circle would be the same as an angle that goes all the way across like that, and that would be pi radians. Similarly, here we're going to get another pi over 2, so it's 1 pi over 2, 2 pi over 2, this is 3 pi over 2. So later on, if we ask you and say, can you draw an angle of 3 pi over 2, you can show an angle that does that much. Or if I was to ask you, where does the terminal arm of 3 pi over 2 end up? So here's the initial arm, the terminal arm would be down there. How about let's look at pi over 4s. So that's going to be half as much as this one, so it's going to be the same thing as 45 degrees. So let's consider where those would end up. So here would be pi over 4. 2 pi over 4 is the same thing as pi over 2. So these are all the multiples of pi over 4. So I didn't write 2 pi over 4 because I reduced it. Here is 3 pi over 4. And this would be 4 pi over 4, which is the same thing as pi. And this would be 5 pi over 4. And I think you see where we're going. This would be 6 pi over 4, but 6 pi over 4 is the same thing as 3 pi over 2. So that's 6 pi over 4. This is 7 pi over 4. So you see we're counting, and this would be 0, or I guess you could also call it 8 pi over 4, couldn't you? But it's the same thing as 2 pi. So you'll notice that we're counting by pi over 4s, but the denominator changes when we can reduce the fraction. Okay, we're half done. Let's take a look at our pi over 3s. Pi over 3s is the same thing in degrees as 60 degrees. Okay, so our pi over 3, if you think that this, okay, here's 0, and here is pi. So that's just like before. So we want 1/3 of that. So if we take this half circle and we divide it into 3, one would be here, another one would be here. So check out the arc. Is that arc approximately equal to this arc, which is approximately equal to that arc? I think I divided it fairly close. So this would be pi over 3. Here would be 2 pi over 3. And then this would be 3 pi over 3, which is the same thing as pi. And over here would be 4 pi over 3. And here is 5 pi over 3. And this is 0, or the same thing as 6 pi, or 2 pi, which is the same thing as 6 pi over 3. For the last one, it's pi over 6. If pi over 3 was 60 degrees, pi over 6 is equal to 30 degrees. And if at any point along the way you forget, what's pi over 6 in degrees? Right, how do you convert radians into degrees, you multiply by 180 degrees over pi, right? So my pi's cancel out. 180 divided by 3 is 30 degrees. So pi over 6 is the same thing as 30 degrees. Okay, it's going to be similar to what we just did, except for we also want to cut this in half, right? So if this was my pi over 3, then this would be my pi over 6. Similarly, if that was my 2 pi over 3, I'm going to cut this part in half. So we're going to get all these, it kind of looks like this. So I'm trying to make them equally spaced. There we go. Alright, so this would be pi over 6. This would be 2 pi over 6, or as we saw it before, pi over 3. This is 3 pi over 6, so that is another multiple. So 3 pi over 6 is the same thing as pi over 2. So I'm not sure if I made them equally. This arc and that arc should all be the same. It kind of looks like this one got a little short changed. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, but that gets reduced to 2 pi over 3. 5 pi over 6. And then 6 pi over 6, which is the same thing as pi. Here is our 7 pi over 6. 8 pi over 6, which is the same thing as 4 pi over 3. 9 pi over 3. Hold on a second. That was 6, 7, 8. Yeah, 9 pi over 6, which is the same thing as 3 pi over 2. Let me just think that. 9 pi over 6. Divide the top and the bottom by 3, so this is equal to 3 pi over 2. This would be 10 pi over 6, so that's the same thing as 5 pi over 3. And this is 11 pi over 6. Okay, I'll do a little bit of erasing there just to make it a bit neater. And that's it for this page, actually. Here, I'll make it look like that. So what this will help you do is solve the questions. Here's the introduction to the unit circle, and we can label all that. And on the following page, if I can scroll forward, determine in which quadrant the following angles terminate. So this will help you determine where they are. So what I'd like you to do now is you can fill in this unit circle. So for example, this would be a 0. This is pi over 6, right? This one will be pi over 4. This one will be pi over 3. And then this one will be pi over 2. Oops, I lost it. Tried to get pi over 2 there. So if you can fill all those in, and we'll take a look at those in class, and then using that sheet, figure out which quadrant each of these in. So we're going to be taking a look at these in class. In which quadrant is 3 pi over 4? So I don't have that sheet with me, but I'm looking at 3 pi over 4. If I count by fourths, right, 1, 2, 3, 3 pi over 4 is right over there, so that would be in quadrant number 2. So try those sheets out. Thank you.